Alright, so we're in the rational expressions unit. I know a lot of people find this difficult because it's a big jump from what we've been doing so far in terms of algebra. So if you're kind of shaky on algebra from last year, I can realize how it can be tough. We're going to look through some of the key skills you guys need. So you need to be able to find equivalent rational expressions. We'll do that. We'll look at simplifying, which is actually the majority of what you need to do. We do that in a number of different ways. And I'll also look at one where we solve. So to start, to find an equivalent rational expression, if you're asked to find an equivalent rational expression, it means take the one that you have and either multiply it by some number or divide it by some number. It's like equivalent fractions from junior high. I've said all the rules from junior high still apply. So we're going to start with this. We're asked to find an equivalent rational expression. Well, your options would be to divide the top and the bottom by something, or multiply the top and the bottom by something. It's much easier in this case to just multiply the top and the bottom by something. So I'm going to multiply the top and the bottom by 2. And that's going to give me a new equivalent rational expression. So you want to put brackets around this. The 2 is applied to each term. So 2 times 2x gives me 4x. 2 times 3 gives me 6. On the bottom, 2 times 2x gives me 4x. And 2 times 1 gives me 2. So this expression here is actually equivalent to this. In terms of it being a function, I talked about inputs and outputs. If you put a number into this, it'll spit out the exact same number that this one would. If you take 1, for instance, 2 times 1 is 2, plus 3 is 5. And then on the bottom, 2 times 1 is 2, 2 plus 1 is 3. So you get 5/3 here. Over here, 4 times 1 is 4. 4 plus 6 is 10. And on the bottom, 4 times 1 is 4. 4 plus 2 is 6. 10 over 6 is the same as 5/3. Right? They're actually equivalent. So these two expressions are equivalent as well. Next, I want to look at one where you're simplifying. And simplifying can be done in a number of ways. You can simplify by dividing the top and the bottom by some number. You can simplify by factoring, which is the main way we're going to do it. You can simplify by adding, multiplying, dividing. So there's a lot of ways to simplify. But this is the equivalent of in junior high where you had a fraction like 50 over 100 and you wanted to put it in lowest terms. This is lowest terms, the algebra version. And it's in lowest terms if I can't pull anything out of the bottom, if I can't factor anything out but 1. If you look at this here, take a look at the bottom there. You need to be able to recognize that. What is that? It's one of the special situations you need to recognize. It's called the difference of squares. We can factor this on the bottom to a y plus 4 and a y minus 4. So if you ever have a difference of squares, two square numbers, it's the square root of the first number plus the square root of the second number, the square root of the first number minus the square root of the second number. That's something you have to have. Now that doesn't help us a ton, but if we factor a y out of the top, you see how there's y squared means there's a y inside here and there's a y inside here as well. So I'm going to factor that out. Y times y gives me y squared, and y times plus 4 gives me 4y. So now that I've done that, it'll become blatantly obvious now that I can cancel these terms. And you really got to be careful with terms. You can only cancel something that's being multiplied to the top and the bottom. This is being multiplied to the top, this is being multiplied to the bottom. They can be canceled. So my simplified version of this rational expression, and sorry I haven't changed the wording on this. This one would have been worded as simplify. I'm simplifying here, I'm not finding an equivalent expression. And I'm going to state my MPVs as well. Here, I'm going to simplify that down to y over y minus 4. Okay. Now this is now in lowest terms. You cannot take anything out of the bottom. You can only factor a 1 out of here. So we fully simplified this thing. It's in lowest terms. Last thing, non-permissible values, they show up everywhere. What are non-permissible values? You can't divide by 0 with rational expressions. Dividing by 0 is meaningless logically, so whatever makes the denominator 0 is not allowed. Some number minus 4. The number that makes the bottom 0 is 4, because 4 minus 4 is 0. So our non-permissible value is y cannot equal positive 4. Okay? And this is the act of simplifying. You're basically breaking a fraction down into lowest terms. Last one I'm going to look at in this part of the video is simplifying again. And again, we're going to state non-permissible values, but it's a different context. Something like this. Adding. You can simplify by adding because right now I've got two terms, but if I combine the two, it's simpler. It's only one term. So I need to add these two. But to add, remember, it's the same as if you go back to junior high. How do you add a half plus a third? If you ever add fractions, they have to have a common denominator. So I need to get this over a common denominator. A good choice, one that will never fail you, is if you multiply the two denominators together. It's not always the best one, but it'll always be there. So a common denominator here would be 5x times 4 for both fractions. The two bottom numbers multiplied together. That will always be a common denominator. Now, on the left fraction, I multiply the bottom by 4. So I got to now multiply the top by 4. So it's now 12. And then over on the other side, I multiply the bottom by 5x. So I now need to multiply the top by 5x. That's important. What you do to the bottom, you need to do to the top. Now, I can put this all over one sign. On the top, I've got this. Now, I can put those two together, 5x times 7x. I could put those two together. 5x times 7x is 35x squared. Okay? Now, from here, you're going to look for something that you can divide the top and the bottom by. Is there any number that goes into 12, 35, 5, and 4? No. And again, to simplify the bottom here, I can write it like this. I can combine these two terms on the bottom and multiply them. But ultimately, it's nice when things cancel. Any common factors for 12, 20, and 35? The answer is no. 5 works for 20 and 35, but doesn't work for 12. 4 works for 12 and 20, but it doesn't work for 35. So the answer is no. If they all had an x, we could pull that out, but they don't. So at this point, we've tried everything. I cannot pull anything else out. I can't pull a 2 out. I can't pull a 10 out. There's nothing else I can take out of this. So it's fully factored. The other thing I need to be aware of, though, is the non-permissible values. What were the non-permissible values here? You've got to be careful when you cancel things. Sometimes you'll hide a non-permissible value. In this case, what makes the denominator 0? Well, 5 times 0 is 0. So x cannot equal 0 because up here you'd have 5 times 0, which is 0. And the same thing down here, 20 times 0 is 0. So x cannot be 0. I got one more to do, which I'll do in another video, which is solving. It's a bit more intense. But again, if I can give you any advice to do these, obviously one, practice. But second, remember that all your fraction rules from junior high still apply. It's actually just the algebra version of junior high fractions. Thanks for watching, and as I said, look at the next one, which will be on solving rational expressions.